Hello. So this is already chapter 9. So we are near the end of the semester already. I'm so happy. And today we are going to start hypothesis testing, which is one of the major statistical inference methods beside the estimation method. So we are going to spend 2 chapters for hypothesis testing because this procedure is a little bit non-standard and it may seem a little bit unnatural and it's more complicated and it's misunderstood by many people. So I'd like to use a lot of examples to help you understand the underlying philosophy behind hypothesis testing, statistical hypothesis testing. So let me start with by comparing the estimation and the hypothesis testing. They are the two major statistical inference methods. But I already mentioned it in chapter 8. The estimation is an open question, what is something? But hypothesis testing is a yes or no question, like is it true or not? So that's the main difference. For example, like a question for the estimation is like what percentage of voters support a candidate, or what is the mean gas price in New York City, right? Something like that. So because there it's an open question, you have to calculate a number to answer the question, right? You have to calculate the percentage or the gas price, right? But on the other hand, well, like the hypothesis testing is a question like, do more than 50% of voters support this candidate? Or is the mean gas price lower than $3 per gallon? It is a closed question because your answer should be yes or no. So of course, your answer must depend on data, but you have to make a decision more than that. Like you not just calculate something out of the data, but you have to decide one of the two answers. Okay, so it is a little bit weird process of decision making. Okay, let me give you a totally irrelevant, seemingly irrelevant example. Suppose that I was charged with a crime and I was brought to a trial. So, but the problem is there is not enough evidence to prove my crime. So, uh, still, I don't have any evidence to prove that I'm innocent. So nobody, like the prosecutor and I myself, have have no evidence at all. Like in this case, what should be the verdict? What would be the how the verdict will turn out? Will I be found guilty or not? So it's not a statistics question, and of course it is just a warm-up question. What I wanted to say here is there is no evidence at all. Then I'm not guilty. I don't need to I don't need to prove that I am innocent. It's just as long as the prosecutor cannot prove I am guilty, I'm not guilty. That's the point. That is called the presumption of innocence, right? Right? So this is one of the most fundamental principles in the modern judicial system, right? So you must have heard about that. So basically it says a person is considered innocent until proven guilty, right? That's basic idea of presumption of innocence. And that also means the burden of proof lies with the prosecution, right? So the prosecutor must prove my guilt, right? That's the prosecutor's burden. I don't have any burden to prove my innocence, right? This is, you do not doubt about it. It's so natural these days as a basic legal decision making process. Okay, so in some sense, but if you think it more carefully, it means that it's unfair. It favors innocence over guilt, right? So if you cannot prove me guilty, then I'm not guilty. So then even if I was actually guilty, but if I could hide evidence well, then I'm not guilty. So this process favors innocence over guilty. So in that sense, it's unfair, but of course in a different sense than the typical fairness. And also, I will like give you more examples of similar decision-making processes like this. Okay, so another example I wanted to show you is paradigm shift in science. Like, uh, geocentrism means the theory that assumes the sun rotates around the Earth. Vice versa, on the other hand, the heliocentrism is what you know these days, like the Earth rotates around the sun. So of course these days heliocentrism is common sense, but in the ancient era, like people believed the geocentrism because it looks like the sun is moving around us, right? So geocentrism was believed like long time ago, but the evidence accumulated the evidence accumulated to prove that something is not right. The geocentrism could not explain the movement of the planets and the sun and the moon. So at some point, like we turned to the heliocentrism. We agreed upon the heliocentrism and just discarded the geocentrism anymore. We don't teach geocentrism anymore outside history, right? So this is similar. Just people believed geocentrism without any doubt. But until it's proven wrong, right? So it's only when the geocentrism was proven wrong, and when there are enough evidence to prove it wrong, when we turn to the heliocentrism. Okay. And the third example I'd like you to think about is your decision making, your shopping habit. Like when you do shopping, you tend to buy the same item you are using, unless you are not satisfied with the item you are using, right? So typically, consumers tend to choose the same products they have been using until they find some problem with the product they are using, right? So, right, usually, right, you know what I'm saying, right? So think about these three decision-making processes like judicial system, presumption of innocence, and this like shopping pattern and paradigm shift, heliocentrism. All those things have something very like have a similar structure to the statistical hypothesis testing. Let me explain in what sense the statistical hypothesis testing is similar to those different examples. Like in hypothesis testing, we are going to compare two hypotheses. Like I believe that the mean true mean is 0. But it could be different. So my research question is, I believe it is 0, but is it different? Yes or no? Or I believe that the probability of heads, like for example, from a coin, I believe that the probability of heads is more than 50% for some reason, but I'm not sure. Is it true or not? So these kind of research problems are statistical problems. And in comparing these two, like in answering this yes or no question, basically we are comparing two things. One is the null hypothesis. It is the hypothesis that is favored, incumbent hypothesis that is believed until it's proven wrong, right? It plays the role of geocentrism or the product that you have been using or the innocence in the trial. Okay, so you have to believe the null hypothesis until you have enough evidence against it. That's the starting point. Usually it's denoted by hypothesis 0. It is called null hypothesis because you believe this hypothesis without any evidence. Just out of nothing, it's believed. Okay? And on the other side, you are comparing the null hypothesis with the alternative hypothesis. This is literally the challenger. The challenging hypothesis, literally the alternative. If the null is wrong, if the null is proven wrong, then you are going to take the alternative hypothesis. That is denoted by H1, right? So because it's alternative, right? As opposed to 0, we use 1. So in statistical hypothesis testing, the first thing you have to do is formulate those hypotheses. Like it's, as I said, the research question is yes or no question. That means you have statistical statements like this, like this and like this. Okay. So they become the hypothesis you are testing. There should be two competing hypotheses. And then, anyhow, in the end, you have to make a decision. Your answer must be yes or no. It's only one of the two. So, or yes or no, like in the hypothesis testing, there are two possible choices, two possible answers. One is to reject the null hypothesis and accept the alternative. And the other is you cannot reject the null hypothesis. Okay? So I said, intentionally refer this to as not rejecting the null hypothesis instead of saying accepting the null hypothesis, because, so let's think about the first case. When you reject the null hypothesis, that means you can reject the null hypothesis only when you have strong evidence against the null hypothesis. That is our approach, right? Our philosophy. The null hypothesis will be rejected only when there is enough evidence. So when you reject the null hypothesis, that is a pretty strong conclusion because you already have evidence. It's like when you are found guilty, that means there should be enough evidence. That already meant your guilt is proven enough without doubt, beyond rational doubt, right? However, when there is not enough evidence, just you don't know what's going on. When there is not enough evidence, then you cannot reject null hypothesis. It is just not rejecting the null hypothesis, but it is not an active acceptance of the null hypothesis because there is no evidence for the null hypothesis, but there is no evidence against it. So we don't have enough evidence either side. So we just keep our null hypothesis just because that's the incumbent, favored, and existing belief. We have no power. Our revolution failed. Our challenge failed. Okay. So that means it is a weak conclusion. It like if you cannot reject the null hypothesis, that may include not enough evidence. Okay. That just means there are not enough evidence against the null hypothesis. So there are two options, and as you can see, by construction, by this decision-making process, the null hypothesis is favored, right? So because if it's clearly wrong, then it will be rejected. If it's clearly true, then it will be accepted. But if it's uncertain, still you are going to accept the null hypothesis. That's where the unfairness comes from. And that also means when you use statistical hypothesis testing for your research, you have to put your hypothesis as the alternative hypothesis because you have to take the handicap for your and you have to overcome that. That's the research, right? So there is an existing theory, but you believe the theory is wrong. Then you have to put the existing theory as the existing hypothesis, null hypothesis, and your opinion as the the alternative hypothesis, and you have to show that the existing hypothesis is rejected and yours is accepted. That's how researchers have to conduct a research or conduct a statistical hypothesis testing. Okay, it makes sense? So, as a summary, like we compared pretty seemingly unrelated examples, but actually underlying philosophy are pretty similar with statistical hypothesis testing. So this is pretty important to understand and interpret your statistical hypothesis testing result. Okay. So in the next video, I will give you another example, which could be seemingly different from all those examples, but will be more specific. I will give you the details of the structure of statistical hypothesis testing. Okay, thank you for watching. See you later.